This is the lesson for 3-1. We're looking at exponents here, and to start with, we've got positive exponents. And so when we are dealing with exponents and trying to simplify them, write them without exponents, we have to understand what exponents are. And exponents are repeating multiplications. So if I was to rewrite this, it would be 10 times by 10 times by 10. So just as multiplication's repeated addition, exponents represent how many times we're going to multiply this base number of 10. And so I go ahead and start multiplying. 2 10s multiply to make 100, and multiply by one more 10, I get 1,000. So something to look for when you've got an exponent to a power of 10, you want to just look at the exponent. It tells you how many zeros you have here. So you see how we have 3 zeros, and there's 3 as the exponent. So just a real quick test on that concept is if it was 10 to the 5th, it would be 1 followed by 5 zeros, so 100,000. Now let's take a look at the next one, and it is 2 to the 5th power, so that represents 5 2's being multiplied together. So what I typically do is just group them, and 2 times 2 makes 4, and then I go ahead and multiply the 2 4's, and I get 16. And 16 times 2 gives me 32. Well, looking at the next one here, we've got a different situation because it's just 5 to the first power. So how many 5's do I write down? Well, here, in the 2's, I had 5 2's being multiplied. Here I had 3 10's. Here I just have 1 5. That's it, not 2 5's, just 1, because that's what the exponent says. And so that would be our answer. So the rule is any number to the first power. So if it was like 7 to the first power equals 7. So that is, any number to the first power is that number. And so whatever we have as the number, it's going to be that number when it's to the first power. So 6 to the 4th just means I'm multiplying those 4 6's. Group those 2 6's together, that gives me 36. 36 times 36, a little tough problem there, but what it comes out to is just under 1,300. It's 1,296, or 1,296. So we got another concept here. Now we've got exponents of 0. So we're going to look at why the answer is the way it is before we even get to it. So I've got this example up here of 2 to the 3rd over 2 to the 3rd. Well, we saw before 2 to the 3rd would be just 2 times 2 times 2. 2 to the 3rd here would be just 2 times 2 times 2. And so that would be 8 over 8. Well, 8 divided by 8 equals 1. Well, let's take a look at the rule. And so we're going to look at the rule before we figure out what a number to the 0 power is. And the rule of division of these exponents is that if I've got the same base, I have the same base, the 2 is the same, I can subtract the exponents. So I'm doing this. So I keep the base the same, I subtract the exponents. That's how you get a number to the 0 power. So we saw before, if we have a 2 to the 3rd over 2 to the 3rd, that just equals 1. And if I've got, and I saw that if I was to use that rule of keeping the base the same and subtracting the exponents, I get 2 to the 0 power. So 2 to the 0 power equals 1. So the rule is any number to the 0 power equals 1. And so we'll see that here. So any number, again, to the 0 power is 1, so 4 to the 0 is 1. This has the negative sign inside the parentheses. It's important that the negative sign is inside these parentheses here, and that does equal 1 as well. And the reason is if it was like this, this is the same thing. This means the opposite of 14 to the 0 power. So order of operations says I have to do exponents first. So the opposite is like negative 1 times by 14 to the 0 power. And 14 to the 0 power we saw was 1. Well, the opposite of that would be negative 1. So that's why it's important to note that in order for us to have a number to the 0 power, if it's negative, it has to be in parentheses. If it's not, then it would be a negative 1. So again, any number to the 0 power is going to be 1. Well, we have another type of concept, and these are negative exponents. And so let's take a look at what the rule is here. So 3 to the first power we saw was 3. 3 to the 3rd power would be 3 times 3 times 3. So if I multiply out these 3's, I get 3 over 27. Well, I reduce that fraction, and I end up with 1 over 9. Or, if I had just canceled these two 3's out, that's the same thing as 1 over 3 to the second. So let's take a look at that rule. So the rule says this. It says if the bases are the same, we can subtract the exponents. And so when I subtract, I'm always subtracting the denominator's exponent from the numerator. So it's 1 minus 3. And that's how I'm getting a negative exponent, because I had more 3's on the bottom of the fraction. So we saw in this example that 3 to the negative second would be the same thing as 1 over 3 to the second. So what we're looking at when we're dealing with these negative exponents is taking the reciprocal. So the rule is, with negative exponents, we'll say with negative exponents, take the reciprocal and the exponents become positive. So that's our rule that we end up seeing here. And so once we get to this stage, then we can just go ahead and multiply out those two 3's, and we end up with 1 over 9. So again, once we see the negative exponents, not a negative number, it just means that we just need to take the reciprocal. It just meant that when we subtracted with the common base, we end up having more 4's on the bottom of the fraction. And so that's why we're left with 1 over 16. So again, the negative exponent just meant that we had 3 6's left on the bottom of the fraction when we reduced the fraction, and that left us with 1 over 216. Again, I got the 216 by multiplying 6 times 6 times 6. And so the 2 6's make 36. 6 times 36 does give me 216. Well, 2 to the negative second would just be 1 over 2 to the second. So again, I had more 2's left on the bottom of the fraction when I canceled things out. And so when I go ahead and do the multiplication of 2 times 2 times 2, well, 3 2's make 8. Then I have another set of 3 2's, and that makes 8. So 8 times 8 makes 64. Well, we've got some other problems that ask us to simplify, so let's take a look at those. And here they are. So now we're going to use those rules to simplify these problems. So we'll start with clearing the exponents, or clearing the parentheses. So I'm going to combine these two numbers, but I'm going to leave that 5 inside the parentheses because it's being brought to the 0 power. And then when I see that negative exponent there, I'm going to just rewrite that as, right now, as 1 over 2. 2 to the first power is the same thing as 2, so I'll write that first power in there for right now. 5 to the 0 power makes 1, and again, that 1 over 2 to the first just makes 1/2. So I combine these two. 9 plus 1/2 gives me 9 and 1/2. That's all a mixed number is, just a sum of an integer and a fraction. So here I'm multiplying 6 times by, and then I have 6 to the 0 power. Again, make sure to keep that 6 inside the parentheses so we can see that it's to the 0 power. 1 over 4 to the negative second just meant I had 2 4's left in the denominator. Go ahead and clearing that exponent, I've got 6 times 1 plus, and then 4 to the second makes 16. So 6 times 1 is 6, plus 1/16 gives me 6 and 1 over 16. So the next one, I just need to take the reciprocal of that negative exponent, makes 2 to the second, so it means I have 2 2's left in the bottom of the fraction. Here I just have 1 4 left in the bottom of the fraction. Well, 2 times 2 makes 4, and 4 to the first power is also 4. So I have 1/4 and 1/4 gives me 2/4, which ends up equaling 1/2. Well, looking at the next problem, I've got to clear these parentheses. So I've got 3 times by 3 to the negative second power, plus, and I'll go ahead and rewrite this as 1 over 9 to the first, and then anything to the 0 power is 1. So go ahead and clear this. Well, it can't multiply yet. I need to deal with the fraction. So 3 times by 1 over 9, or 3 to the second. So I'm going to go ahead and show that step there. So I've got 1 over 3 to the second, and then plus the 1/9 plus the 1. So now I need to multiply. I've got 3 over 1/9 plus 1/9, and then plus 1. So I still need to multiply here, so I'm going to reduce a little bit. And so now I've got 1/3 plus 1/9 plus 1. And when I combine those, I've got to come up with a common denominator. So I'm going to multiply this by 3/3. So that leaves me a 3/9 plus 1/9 plus 1. Well, now I'm left with 4/9, and when I add 1 to that, I just get 1 4/9. Well, taking a look at this next one, 9 to the 0 power is 1, plus 64, and then times by 8 to the negative second. So 8's being brought to the negative second, so that just makes 1 over 8 to the second, times by 64 plus 1. Well, when I go ahead and multiply those two 8's, I see I get 1 over 64. And this is being multiplied by the 64. So what happens is these 64's cancel, but it's not left with 0, I'm left with 1. 1 times 1 is 1, so I still have to add those two 1's, and that's where I'm getting 2 from. Over on this one, I've got 15 plus 1, 6 to the 0 is 1, plus 1 over 3 to the second. So 15 and 1 plus 1/9 gives me 16 plus 1/9, which gives me 16 and 1/9. Well, we've got a problem that deals with half-life here, so let's take a look at that. It says that the half-life of caffeine is 6 hours. And so what that means is after 6 hours, there's only half of that amount, a half left. So after 12 hours, there's half of 1/2, which is 1/4 left. After 18 hours, we take a half of that 1/4, and that gives me 1/8. And then another 6 hours would be 24 hours. And so if I take half of that, that's going to end up being 1/16. And then half of that number to make 30 hours total, that'd be 1 over 32. So basically I'm taking 1/2 and I'm multiplying it 5 times. So 1/2, 1/2, 1/2, 1/2, 1/2. And so that makes 1 over 32. But they wanted us to write that as a fraction, which we did, and as a negative exponent. So you see all those 2's, that just makes 2 to the 5th. Well, 1 over 2 to the 5th is the same as 2 to the negative 5th power. So another way we can do that is see that we had 5 groups of 2's here. And I could have divided 30 by 6 and got those 5 numbers. So I'm going to do that here. I'm going to divide 42 by 6 to find out how many half-lives I have. Well, that's 7 half-lives. So that means it's going to be 1 over 2 to the 7th power. And so if I go ahead and multiply that out, that makes 1 over 128. And if I wrote that as a negative exponent, it would be 2 to the negative 7th power. So those are the types of problems you're going to see on tonight's homework. Good luck.